Already clear, Arka. Right? Thank you. Yeah, very good morning. Good evening, sorry. Okay. So let me start with today's lesson plan. So I think last class we just ended with the introduction of rocks. We really did not step into geomorphology properly, isn't it? Like today there are two topics which are largely connected, so we can definitely finish that. One is interior of the earth. Interior of the earth. Second is continental drift theory. Continental drift theory. And connecting these, we'll be having formation of fossil fuels. We need to investigate that. So after this, like it depends upon whether time permits or not. Once CDT is done, CDT is quite a comprehensive theory. So let's say we finish it, then we might be stepping into geomagnetism. Like that will work out based on time. So under geomagnetism, we have two related concepts. One is paleomagnetism, and then second one is seafloor spreading. So that is a lesson plan, but these two will definitely be done. Okay, we have quite some time, but the others I really can't predict. Okay, so let's start with interior of the earth. Okay, so interior of the earth. Right. Let's understand why this was important first of all. Okay, see, once if you start to think about the last 200 years of scientific progress, it started with industrial revolution. And as usual, if you look at the reason why people were interested, it was to basically study what is going to be my mineral deposition. Okay, it technically starts with minerals, because at the end of the day, whatever you find with reference to the earth, how far can I put it to good economic use? So everything comes down to that. And after minerals, if you looked at the second most important relevance, why you should be studying the Earth's interior was with disasters. Because disasters struck not frequently, but when they struck, even rarely, let's say a span of 15 years or 20 years, disasters were very powerful. So you really wanted to know what goes on in the center of the Earth, like what is exactly there. So apart from speculation, which is obtained from mythology, there were serious attempts which were made by scientists to really understand what went on in the interior. So at the start, the studies were not really comprehensive. Okay. So at the start of the study, okay, when they wanted to study what exactly is there, okay, uh, they did want to use material which were derived from several sources, and most of the sources were indirect in nature. So first we need to appreciate why it was indirect sources. Why wasn't it simply sources directly obtained from the interior itself? See, the biggest problem with the study of interior is physical limitation. Okay, physical limitation. Now, if you want to pick up a rock which is present, let's say 1,200 kilometers from the surface, it will not be possible for you to take that material and see what exactly it is. Why? Because even today, we do not have the technology to penetrate the Earth's interior, take a material, and then come back again. It's simply not possible. Why? The temperature is way too high. Okay, we do not have metals or any elements or compounds which can withstand high temperatures as you keep moving beneath. That was a major restriction. So if I have a physical limitation, then I am naturally inclined to explore what are my sources. How can I try to understand? So there were primarily three indirect sources, three different ways in which they try to understand the interior. So first was simple, like it's something which you can just look into it and say, yeah, this is an obvious source. First one is volcanic eruptions. Okay. So materials, fine. So source number one, materials obtained from volcanic eruptions. Volcanic eruptions. Think about this. If it's not possible for you to really go inside the interior, then no problem. Well, already materials are getting thrown out whenever there are areas of volcanic eruption. So what you do is you collect these materials and then try to understand what is their composition, a simpler method, right? So second one is again, is something which is driven by mineral exploration. You take by 1850s, 1860s, or that is the time when industrial revolution is appreciating the importance of one black color liquid called as oil. By 1900, people are beginning to realize, because that is when your automobile is beginning to pick up. The invention of the automobile finally happens. So slowly they know that oil is an important source of several petrochemicals. That happens very, very late. Once they understand that, they develop machines which can dig in several kilometers. Now, when we use several kilometers in this case, we are talking about 8 kilometers, 9 kilometers, but back then that was quite high. Okay, so you are relying on materials excavated excavated during mining, oil drilling, because now we are going quite deeper. What was not possible several years ago is now made possible because you're interested in oil, which means you're going to dig much, much deeper. And third is quite an unconventional indirect source. Third one was meteorites. Meteorites. And I believe you know what they are, but still, let me give a briefing. Okay. See, any cosmic object, it can be any material. Okay. If this object is able to enter the Earth's atmosphere, 99.99% of the time, this material will burn. Why? Because of friction in the atmosphere. Especially when it comes closer and closer. Let's say it enters the exosphere, not much number of molecules. Once it enters ionosphere, then mesosphere, the thickness of the atmosphere is going to slowly, actually not slowly, quite rapidly increase, because you know that most of the atmosphere is at the bottom. 99.99% of the time, this will burn out due to friction. Very rarely, this object, if it is very, very large, might reach the Earth's surface. So any cosmic object able to reach the Earth's surface is called as a meteorite. It's able to breach through the Earth's atmosphere, reach the Earth's surface. Now you might be wondering, how is a meteorite an indirect source? Well, it works like this. If this object is there in the solar system, there is a very good chance this is related to the Earth. Related to the Earth. Because most of the star dust and chondrules which you find in the solar system will one way or the other be related. See, for example, why are we interested in studying Mars, Jupiter and Venus? Of course, apart from trying to understand whether there is any habitable life on these planets, we also want to know what is the surface composition, how close it is to Earth. So if there are meteorites which enter the Earth's atmosphere, and you can definitely take it up and look at the materials, there are chances that the materials in meteorites might be giving us clues on what exactly is present in the interior also. So there are three different methods which were widely used for understanding, okay, to the Earth's interior. So as I told you, like, these are good but very ineffective, because you can only go for speculations. You can go for speculations and still present okayish kind of models, but they're not going to really help you in progressing in science, because when it comes to science, you need better verifiability. Apart from verifiability, you need certain workable models, okay, which is acceptable. So things take a different turn, a positive turn, when they associated themselves, when these scientists associated themselves with an evolving fields, okay, the field of seismology. Is it clear? The exploration of the interior became better when the studies associated themselves with the field of seismology. I'm pretty sure you all know what this is. You're talking about earthquakes. Fine. So see, everything goes parallelly. Like, one is a separate domain. A group of people are studying the Earth's interior, one are trying volcanic eruptions, one person is studying rivers, and one person is studying earthquakes. There are different departments in the university. So each and every individual tries to comprehend and understand each other. Is it clear? So first, we need to understand, like, what exactly is an earthquake, and what are the points in which energy is released, because we'll be using those terminologies, and what exactly is a seismic wave. So it might seem to be a slight deviation from the topic, but actually understanding these fundamentals will be essential for appreciating the Earth's interior. So I will read this statement, then I'll flip over and give you the basics of what is required, just enough for exploring the interior. Okay. So the exploration of the interior became better when the studies associated themselves with the field of seismology. Fine. So what exactly is an earthquake? Ready? Earthquake. Earthquakes are oscillations of the earth crust, oscillations of the earth crust. Okay. The energy released during these events, during these events travel in the form of waves, called seismic or seismic waves, however you want to call it, seismic waves. Okay. So now we need to understand two more points, like what exactly is a focus and what is an epicenter. Hmm? So earthquakes are technically oscillations. Fine. So because the Earth's crust is actually, like you will learn it in one more theory, like plate tectonics, it's actually under constant motion. So because of several factors which happen, which happen beneath the Earth crust, okay, certain parts of the crust will get compressed, certain parts will experience tensional forces. So when these compressional forces and tensional forces operate, like similar to our bones getting fractured, the Earth's crust will break in several parts. So when this breakage happens, there will be oscillations which are spread across to the world. Those are technically earthquakes. So earthquakes are very normal phenomenon. Only thing is they affect us deeply because we are trying to have some sort of stability in life. That is the issue. So the energy which is released is called as seismic waves, and based on this, you have two different terminologies called as focus and epicenter. Ready? So focus is the point of energy release, because you know that, okay, earthquakes is a subsurface phenomenon. It's not immediately going to happen where you stand. It happens few kilometers below the surface. So first is focus. Focus is the point of energy release in an earthquake. And the one which is immediately above the focus is called the epicenter. Epicenter. Epicenter is the point immediately above focus. Okay, so the point of energy release plus where exactly you are standing. Right. So shall I flip over? Let me know. You've taken this down. Yes, several responses. Thank you. See, now we are to explore one important point. The point is related to what exactly are seismic waves and what is a broad classification. See, and please understand it here itself. Okay, later it will be useful. That is why. See, if you take a point of energy release, I'm going to, since the focus and epicenter are not very far away, usually they're very close by, I'm going to approximate them as a single point. Look at this previous diagram. Okay, like technically, the epicenter is immediately above the focus. That's the shortest distance. Okay, you draw a perpendicular line. So I'm trying to merge both those points to keep our discussion simple. But actually, they are separate. So I'll take one single point. Now, the energy release is going to happen in two different forms. That is how we classify seismic waves. Seismic waves are classified as body waves and surface waves. Okay, so one group of waves travel along the interior itself. They are not going to travel along the surface like this. These are called body waves. Body waves traveling along the interior. There is one more set of waves which will travel along the surface. Okay, like this. These are called as surface waves. Okay. Surface waves along the surface. This is the broad classification. Primary waves and secondary waves come later. Okay. Surface waves body waves. Surface waves travel along the interior of the Earth, and body waves travel along the surface waves travel along the surface, and body waves travel along the Earth's interior. Now, at the start, when I show you this picture, you will not have any issues. You will tell me that you are understanding it. But let me clarify better. Because you will ask me a doubt later, 35 minutes later, when I finish this topic. And let me try to avoid the doubt by here. I will not tell you the question. Let's see whether the question comes today. Half பண்ண முடியுமா? இல்ல half பண்ண முடியுமா அது? என்னோட display. Hold on a sec. I can't see myself. I'm way too small. Only then I'll get an idea whether what I'm doing is reaching you or not. We'll continue. Citizen people. This is the Earth's interior. I mean, this is Earth, not Earth's interior. This is Earth. Okay. See, understand, you cannot exist inside. You cannot exist here. You can exist only along the surface. For example, you see this red color column right here. This is India. Okay. Opposite side, this is North America. You get it? Now? Thank you. Yeah, this is India. Yeah, this one. This red color column is India. Fine. The one which is opposite is going to be North America. The sharpened section. So, if you're going to have an earthquake, possibly it is on the India-Nepal border, the energy can travel in two ways. Please listen. Yeah, this will do. See, if your energy is going to travel along the surface, that is from India, the energy is traveling from India, the energy travels, let's say, Myanmar, then Myanmar, Thailand, then crossing the Pacific Ocean, maybe Fiji. After Fiji, then it comes to maybe Hawaiian Islands. After Hawaiian Islands, it's going to United States of America. If the wave is going to travel this way, okay, like along the surface, you call it as a surface wave. You got the idea. Now, please listen. The diameter of the Earth is close to 6,000 kilometers. Now, look at this. You can have an earthquake in Nepal on the surface, and energy will try to travel to United States using a shorter distance. You know how it will start here, like inside, like it will travel along this direction. Okay, this way also I can reach United States. So two ways I can reach United States. I can take a route which is moving along the circumference of the Earth this way. At the same time, I can start here and then end here immediately. So if I start and end here, okay, just traveling within the Earth, that is called as a body wave. Fine, I start from India, encircle the circumference, then reach Los Angeles, then I'm called as a surface wave. The interior one is body. Okay, like one in the center. This is body. Like when I place my hands in the center and play, this is body wave. Surface waves will only be on the exterior region. Never ever get doubts. Shall I proceed further? Shall we? Right, several responses. It will be useful later. You will need it. Let me tell you now. See, now we'll try to classify body waves. Body waves are further divided as primary and secondary waves. Okay, why the words primary and secondary? Because it is based on the time the wave is received at the seismograph or the instrument. Okay, let's say you're having an instrument in Japan. So the first instant of recording the event is technically called as primary, the initial wave. Secondary waves will reach after a time delay. Is it clear? Now, these two waves have a fundamental property, and that is very important for determining the Earth's interior. Fine, so let me write the statement, and we will explore what property too. Body waves are further divided into primary waves or P waves, secondary, which reach after a time delay, secondary waves or S waves. Okay. So primary waves and secondary waves have this difference in time delay because of the method they try to transfer energy through a medium. Okay, you're asking what method they are trying to transfer, or how are they trying to transfer energy? Let me help you out. I'm drawing the molecules close by to indicate that this is a solid medium. Okay. The molecules are separated to indicate that it's a fluid medium, because in a fluid medium, you don't have a perfect shape. Okay, the molecules are quite widely spaced apart, right? So maybe this is again fluid medium. You take your primary wave, when it tries to transfer energy, for example, let's say there is point A, there is point B, and same here also. I'm trying to transfer energy from point A to point B. This is my direction of energy flow. Energy. Right? Now, when I'm going to transfer energy, P waves make the particles vibrate along the direction of propagation. Along the direction of propagation. 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 See, along the direction of propagation, let's try to visualize like this. I'll need it later. See, listen. This is particle 1. Okay, this is my hand. Like, let's say 4 molecules. Particle 1, particle 2, particle 3, particle 4. Now, when you try to transfer the energy along the direction of propagation, the particles vibrate like this. A to B, 1. So it's like you try to land a punch. Meaning makes sense. So this is along the direction of propagation. So you vibrate the first molecule, second molecule, third molecule, 4. The energy reaches point B. Meaning makes sense. So along the direction of propagation, the energy will get transferred in a solid medium. Perfect. So P waves have a natural ability to transfer energy through a solid medium. You start from point A, it will reach point B. No problem. Fine. Come to secondary waves. Secondary waves will transfer energy, okay, by vibrating particles, okay, perpendicular to the direction of propagation. Direction of propagation. What do you mean by perpendicular? Same example. Okay, thing is 1, 2, 3, 4. Okay. So when I say perpendicular, and let's say this is my direction, I'm moving in this way. Perpendicular can mean two things. Either the particles are vibrating like this way, okay, 90 degrees. I can't put, not Hrithik Roshan or Prabhudeva. This one, like this way. This way you can either oscillate or you can vibrate it this way. Meaning makes sense. So that is being perpendicular at 90 degrees with your normal. Meaning makes sense. So this is 90 degrees or this is 90 degrees. You get the idea? So when I say perpendicular, see what happens. I move molecule 1. Molecule 2 moves, molecule 3 moves, molecule 4 moves. So I will be in a position to transfer energy in a solid medium. No problem. Same thing here also, no issues. You can vibrate this way also. 1, 2, 3, 4. Energy is getting transferred. So if you're going to vibrate it perpendicular, energy will get transferred. Energy is going to get transferred. Why? Because in solid medium, all the particles are getting connected. No problem. So energy will move from point A to point B. No issues at all. So both P waves and your secondary waves will pass energy through solid medium. They have absolutely no problem. Things get trickier when you take fluid medium, because in fluid medium, the particles are not connected. Fine. So let's take the same game right now. So these are two particles. Particle 1, this is particle 2. Let's try to transfer energy, point 1. Okay. You push it up. Actually, if you try to make the particles vibrate along the direction of propagation, energy will get transferred. Why? Distance might be there. That is not a problem. Chair goes or not, if you give enough energy, it'll go and hit the podium even further. Distance is there. Energy is transferred, no problem. So in a fluid medium, energy will get transferred without any issues. See, this is how you play snookers and billiards, isn't it? You hit one, then all the balls reach the end. So energy is getting transferred, no issues. So fluid medium, not a problem for P waves. Got it? So P waves can travel in both solid medium and fluid medium. You just saw me pushing the chair, even at a distance. S waves can pass it through a solid, not an issue. Now when you try it for fluids, things become tricky. Now see what happens. Point A to point B. Perpendicular to the direction of propagation. I'm particle 1. I want to transfer energy to particle 2. Look at me vibrating. I'm not vibrating like this. That's not the way I'm vibrating. I'm vibrating like this. I stand here and I start jumping. Nothing's going to happen. Or I start moving right and left. Absolutely nothing's going to happen. The energy will remain in the same place. Meaning makes sense. So when there is perpendicular vibration, there is no way energy is getting transferred. This is why secondary waves pass through solid medium, but not through fluid medium. You got the idea? They cannot do that. Hmm? Fine. So once you finished it, use the word finished. This is a very fundamental difference between P waves and S waves. All right. P waves can do both. S waves can do only one. They can do solids, but liquids not possible at all. They can't do it in fluids. Two responses. One more, I'll proceed further. Three. Right. Got it. Fine now. This is the property. I haven't explored interior at all. Thing is, they start learning seismology and they study primary waves and secondary waves, and now they think maybe I have an idea to explore the Earth's interior, because look at the heading. Now you need to focus on the heading. Body waves. I'm not talking about surface waves. I haven't talked about surface waves at all. Surface waves, I will tell you about when we discuss earthquakes. Surface waves are the most destructive. That is what we come in most contact with. But for scientific study, body waves are essential, because my intention is to explore the Earth's interior, after all. So if I study body waves, by exploring the movement of body waves, I will understand what exactly is there in the Earth's interior. So that is how they came to the conclusion, maybe we should focus more on seismology. And they did. Okay. So my theory will develop like this. We will look through a series of 3 observations. Through 3 observations, our theory will get modified. It's never like you don't go to the final diagram straight ahead. There are 3 important breakthroughs which they achieved, 3 important observations which they actually got. So observation, then based on observation, I write my theory. Then second observation, based on that, I write my theory. Third observation and theory, right? So now I want to add one more statement. You should be understanding this. If you want to study earthquakes, you cannot do it as a single country. Now, what do I mean? If you really want to locate one particular earthquake, or you want to really analyze what is the difference in frequency, what is the difference in amplitude, where exactly to narrow down, all these things will work out when you work as a different set of countries. See, one of the important, or let's say positive things which Britain did when they colonized several parts of the world, is that they started establishing laboratories, museums, at the same time zoos in different parts of the world. Okay, you take the National Laboratory, which is established in India. British people, you take Geological Survey of India, several organizations, Botanical Society. Every organization, one way or the other, will have the touch of British. Why? Well, they did it for the exploitation of resources. That is the reason they did. But point is, they are bringing instruments to different parts of the world. So now if there is going to be an earthquake, different parts of the world can record them. And now you have ability to compare. So once you can compare, based on comparison, you can say, okay, this is where the earthquake started. The earthquake reached late. The energy reached late. The energy really did not follow a certain pattern. Fine. So let me start with the first observation. And before the first observation, okay, you need to get something related to what happens in a swimming pool if you drop your key. Pretty sure you experienced this at least once when you were not comfortable with swimming. Not everyone is comfortable by the first time you are put into a pool, right? Or a well. This is you standing in karate position because you still do not know swimming. You're trying to learn. Okay. This is water. Air. You dropped your key. You're afraid because you still haven't learned it. You're very young, still haven't learned it, but you want to pick up your key. Pretty sure this will have happened to you. If you look at the key's location, it will actually be in a position. But at the same time, you put your head inside water, then look for the key. The key would have moved at least few feet away. Okay, at least few inches away. Pretty sure you experienced that. See, this happens because light is getting refracted. Fine. Whenever a wave moves from a rarer medium to a denser medium, it moves away from the normal. Okay. This is called a Snell's law. Based on this, you would have studied refractive index in physics. Automatically, law students will come. You're using complicated words. This was never taught in school. This was taught in school even before 11th standard. Pretty sure you finished 10 to get your graduation done. Point is, we are not trying to make you understand about refractive index. The concept is only about refraction. See, whenever a wave is present, and let's say the wave makes a transition between 2 different media, for example, in this case, air to water, or reverse, possibly a light source from water moves away from water, then enters air. It will not follow a straight line. You want a straight line, you'll be in the same medium. Same medium, the light will maintain its straight path. You get it? This was a fundamental observation. You're like, fine, so what observation did they actually do? See, initially it was thought, let me write that for you. Initially, it was thought, sorry, initially it was thought that the Earth's interior was made of a single material. Earth's interior was homogeneous. Homogeneous. So this is my expectation. I already thought about it. See, early 19th century, we don't have much data at all. I'm just trying to write my theory. So I just believe that it was homogeneous. But actually, if you're having a homogeneous Earth, okay, and I start from point 1, and if you expect a release of energy, this is how the energy should travel. A wave should travel in straight lines. This was the expectation people had. But actually, data was different. But based on data, it was understood that the body waves experienced changes in velocity and they refracted Okay, so what? This was not true. This was never observed. The first observation was this. First observation is this. From the point of energy release, waves are moving in refracted paths. Okay, so this is my first observation. Read it again, but based on the data, it was understood that the body waves experienced changes in velocity and they refracted. This is my first observation, confirmed by collecting data from several locations in the world. Okay, now this properly indicates one important refutal. This is wrong. This assumption was wrong in the first place. If you are going to have refraction, refraction is possible, as we discussed in the previous slide, only if there is a change in medium. So refraction indicates that the Earth is not a homogeneous medium. Okay, it indicates that Earth is heterogeneous. This indicates heterogeneity of the interior. Heterogeneity. All right, heterogeneity. Okay. That's the very first observation. Gladly accepted. Use the word finished if you're ready. We'll go to the second one. On response. See, it's like slowly. Only now we are touching it and seeing. Just touching it. Just seeing it right now. Slowly we're exploring. Moving on. Now I know one thing for sure. Earth is not made of the same material. Now we need to understand that second exploration is to do with S waves. And let me paint a picture on how things will actually get restricted. So now we are actually trying to monitor S waves. See, visualize a condition where seismic instruments are established in different parts of the world. This is what I do. North America, South America, Africa, West Asia, India, Sumatra, Australia, Indochina, Siberia. Listen carefully. Earthquake is right now there in Chile. There is an earthquake. It's highly prone to earthquakes. Now from Chile, assume that the energy is getting traveled. Fine. So energy is, you are going to receive both your primary waves and secondary waves. The body waves are going to reach your instruments first. After receiving, I'm making phone calls from Chile. Listen carefully. These phone calls for this, I just want to know what time it reached it and what is the intensity of the earthquake. So I make phone call to United States. USA, received the earthquake, give me information. So Los Angeles, they say, yeah, we received it. This is the input and all that. Received. Okay. I travel towards the western side further. Okay. I call Hawaiian Islands. Hawaiian Islands says, yes, we got it. No problem. Travel even further. Across the Pacific Ocean, make a phone call, okay, to Australia. Okay. Australia says, yes, we did receive information. So Australia says, yes. But when I make the phone call, let's say to Indonesia, I make a phone call to Indonesia. Indonesia says, no. Okay, calling Indonesia, what do you mean by no? Indonesia says, I do not have any information on S waves because I did not receive secondary waves. You want to make a confirmation. You call Myanmar. Myanmar also says no. There is no information at all. Myanmar says no, man. I don't know. I do not have any information on S waves. You're really confused. So point is, from the point of energy release, if you keep moving up to a certain distance, you are receiving a secondary waves, but after there is nil reception. You are like, okay, why don't I try the eastern part? From the point of energy release, the eastern segment. You make a phone call to, Brazil. Brazil says yes. Okay. You come to Spain. Spain says yes. You come to Nigeria. Nigeria says yes. Make a phone call to United Arab Emirates. United UAE says no. No. You phone call Pakistan. Pakistan says no. We don't have this information on S waves. You ask Pakistan clearly. They check your instrument properly. Your instrument only no. Information is there or not? Sir, definitely not there. Sir, today only we installed. No information. So again, there is a problem. The problem is this. That is, from the point of energy release, you travel towards the eastern side. I get reception, then no reception. I travel towards the western side. I travel towards the eastern side also. Reception, then after a point of time, there is no reception. So you get a region where things are becoming totally blank. Now, how do I represent this on the interior map? Like, this is the actual world map, right? So when I represent it, how will you represent? That's more important. Second observation. Second observation, detecting S waves. Detecting S waves. Listen, focus. Point is Chile. See what happens from Chile. Okay, listen, like, how do you actually draw and how do you come to the conclusion? This is not explained in NCERT, that's why. From Chile, received in USA, received in Hawaiian Islands, received in Australia, maybe the associated island of Fiji also. But once you make a phone call to, let's say, possibly one more country, we saw, no? Myanmar says no, right? Thailand says no. All the other countries are saying no. Come to the other side. Make a phone call to Brazil. Brazil says yes. Spain says yes. Togo says yes. Nigeria says yes. No problem. By the time you make a phone call to UAE, UAE says no. Pakistan says no. India also says no. They say, no, man, we don't have anything. So to an extent, there is detection. To an extent, there is detection. So the thing is, from the point of energy release up to 105 degrees, 105 degrees on the western side and 105 degrees on the eastern side, there is detection of X waves. After that, there is absolutely no detection. Now, what does this 105 mean? I think you would have guessed it already. 105 means the longitudinal region, the longitude. You get it? Second point to be noted. When I say 105, I do not mean 105 west, 105 east. No. I'm talking about walking 105 degrees of longitude on the western side from the point of energy release. Same thing, 105 degrees longitude from the point of energy release to the eastern side. So this 105 will keep changing. If I put my X mark here, it will change. If I put my X mark here, it will change. From the point of energy release, 105 to the west, 105 to the east, everywhere S waves are present. But after this, there is no detection. This is called as this one, this region, where there's no detection is there. No? This is called shadow zone of S waves. Shadow zone of S waves. Got it? Now, this is my observation. I'm just seeing the data. I receive the data, I'm seeing this. Now, I know one thing. Something is there in the center. Correct? I don't know what it is, but something is there in the center. This material has made sure that the waves are not reaching the bottom, or the waves are not reaching all parts of the earth. But I do know one thing. Based on my laboratory analysis, I definitely know that S waves do not pass through liquid medium. That is when they changed the theory. Based on my observation, the theory was modified. Now I'm writing theory C. They said S waves do not pass through liquid medium, so the medium which is present in the center should be a liquid medium. That is the only plausible explanation. All right. So now they identified that there is presence of liquid medium in the center. Not the idea. So this is how they found out that there is a presence of a liquid medium. That's the way it is done. See, I have drawn it in one picture. For this, they took several years. Years and years together. First, one group of scientists will publish it in one journal. Then after that, it has to be peer reviewed. Data has to be verified. Again, second time, third time, multiple verifications, then they will accept. Okay. Like nothing in no progress in science has happened immediately. It never does. It might seem like that, but never. A person comes up with a theory, questions, several times. After that, finally they will say, okay, sir, you're right only. So shall I move on? This is second observation. Third will be even more interesting. Right, stepping on, believe you've copied. Yeah, moving further. Third observation. This time, I'm going to look at P waves. Observation. North America, South America, Africa, West Asia, India, Malaysia, Sumatra, Australia, Indochina, and Europe. Same place, Chile. Right? Again, Chile is making phone calls. See, now before starting, we'll understand this. Primary waves have the ability to pass through both solid medium and liquid medium, which means presence of the liquid medium should not disturb P waves, but we'll see what happens. Again, phone call to USA, no problem. Phone call to Hawaii, yes sir, P waves are present. Yes sir, P waves are present, no problem. Travel west. Come to Australia. Okay, he says, yes sir, P waves are present. Phone call to Thailand. Thailand says, no sir. You're scolding him. Say, P waves can travel through both. Check your instruments, sir. No, sir. Absolutely not, sir. P waves not there. Making phone call to Myanmar. Myanmar says, no, sir. For verification, you're calling India. India says, yes, sir. You're again asking India. India, don't play with me. Really, you told me to detect P waves. Yes, sir, I detected P waves. Okay, fine. India, I trust you. See what has happened? You have into marks. Okay, but after a certain region of no detection, okay, you do find some amount of P waves. Is it clear? Now let's come to the eastern side. Sorry, the eastern side from the point of reference. Phone call to Brazil, accept. Phone call to Spain, accept. Phone call to Nigeria, yes sir, P waves are there. Come to the eastern side, even Egypt says okay. Come to United Arab Emirates, United Arab Emirates says no sir. Saudi Arabia says no sir. You come to Armenia, Armenia says absolutely not sir. Get it? So again you get into marks. P waves are not detected. You're really perplexed. One last time for confirmation, you're asking Pakistan. Pakistan, did you receive? Yes, sir. The India I will trust. Seriously received. Definitely, sir. Financial Action Task Force, so you know what I've done. No, I've arrested the person. See, I'm actually following the rules. The instrument is working properly. Yes, sir. You get it? Now, this is more of a complicated situation. We'll try to represent this on the map. Shall we? See? P waves observation. Third one. Third observation. Primary waves. Okay. From the point of energy release, there is detection. Chile, United States, Hawaiian Islands, Australia. After that, there was no detection. Thailand, Myanmar. Again, there was detection in India. There is confusion, right? Come to the other side. No detection in Brazil, Nigeria, Togo. There is detection as far as Egypt. No problem. You come to United Arab Emirates, no detection. Ask Saudi Arabia, he scolded you. Armenia said, we'll never obey you. Okay, there is absolutely no detection at all. We won't give any information. You call Pakistan, what did Pakistan say? Pakistan said yes. This is a complicated issue. That is, you do have a shadow zone, but shadow zone is kind of in the center. Okay, what are these angles? Well, the angles are these. Between 105 degrees and 145 degrees, there is absence of P waves. This is very complicated compared to S waves. In spite of the fact that P waves can pass through between 105 and 105, this region, you do not have P waves at all. So let me write it here. So this is called the shadow zone of P waves. Shadow zone means no detection. Shadow zone of P waves. It's between 105 and 145. Now I'm really perplexed. I am the geologist or geographer. Okay. Now we'll need to put theory for this. I will write theory. Don't worry. First, we should understand what is already there. Already liquid medium I put, which means I simply cannot say liquid medium. They will scold me. Liquid medium is there also. There is there is no detection. P wave should have passed through. Look at my theory. To understand my theory, you should understand my genius. Okay, I will take an analogy. Please hold on a second. Please hold on a second. Understand this analogy. Just a second. We'll go back to swimming pool. Same karate position. Don't know swimming. Okay. Water. Kisnile. For those who do not know Kisnile means kerosene. Don't worry, it won't burn. அதுக்கப்புறம் ஒரு ginger oil. Neck what I will pour? Neck leave, neck nothing. Already your clothes would have collapsed. Okay, listen carefully. This is air. Again same key. Assume that you have the ability to see through all this. Key is there. Now, if you try to put your head after all these things, you try to see inside water, key will move 10 feet. You know why? See, if you have only one single medium, already you experience refraction. Now, when I have 1, 2, 3, 4 mediums, if you look at the initial wave direction, you know how many refractions will happen? So many refractions. Finally, the final wave's direction and initial wave direction, there will be absolutely no relationship because multiple layers are possible. Concept you understood? No? When you have multiple layers, initial direction and final direction become totally different. Scientists are thinking, okay, you want explanation? No, I will explain. Already we have liquid medium in the center. Liquid. If you want multiple reflections, they stated, assume a solid medium in the center. Got it? Now, beyond the liquid medium, there is already a solid medium in existence. Now, see what happens. Point X. Energy is released. So, when energy moves along this direction, already there will be a first level of refraction because you're trying to move from a solid medium to a liquid medium. First refraction, 1. You try to move across this area, actually you should be in a position to reach here. Like this is the expected path. You should be in a position to reach your shadow zone, but it doesn't happen because by the time it comes here, okay, it interacts with solid medium again. So this is transition 2. Now we are moving from liquid to solid, point 2. Second refraction. Then you enter this area. Solid to liquid. You're exiting the solid medium, entering the liquid medium, point 3. Again, fourth refraction. Okay, this is point 4. This is again liquid medium to the outer solid medium. So once a wave experiences 4 refractions, your initial direction and final direction won't be same. It kind of go here. Okay, so that is how they actually, finalize their theory. They theorized to explain the shadow zone of P waves that inside the liquid medium, there is a solid medium. Okay, that's a very, very big statement, and it's essential for explaining the magnetosphere also. Actually, this works. Is it fine? So let me write this here. They theorized the presence of a solid medium inside a liquid medium. Solid medium inside a liquid medium. Because, let's write it here at the last, multiple refractions, complete change in direction. That's all. Complete change in direction of the wave. Is it fine? This is a very important statement. So of several observations, which we will see, like the final diagram we will see, of several advancements, this is the most important one, where they agree that there has to be a solid medium in the center. Only then it would be not possible for such a powerful wave like P wave to not reach all the parts of the Earth. It is made possible only through multiple refractions. Okay. Thing is, this section is not, it is there in NCERT. I'm not denying that, but not with diagrams. It's not very clear. So this is how the evolution of the interior was properly understood. And I'll read the statement, then I'll move on. They theorize the presence of a solid medium inside a liquid medium because multiple refractions can be explained, because that is the way complete change in directions. Multiple refractions cause complete change in direction. What is this solid medium? You'll get the answer in the next slide. It's mostly done of iron. Okay, it's technically iron. What do you find in the center? Large amount of iron. Hmm? Center of the earth is solid. Yes. Yes, yes, yes. Shall I move on? We'll forget the final diagram. Right. See, after this, I've spoken only about the major breakthroughs. I haven't come to each and every layer, isn't it? After this, as your studies become more and more severe, like I just tell you like what several adaptations they did. See, based on two locations, if two locations are there in the earth, okay, like if they're going to refract, okay, based on your time, based on your distance, you will be in a position to calculate velocity. So the studies began to move more and more towards velocity change. So, and they tried to superimpose, see, if velocity is if the waves are moving through, let's say, carbon, how will the velocity be? If it is moving through phosphorus, how will it be? If it is moving through silicon, how will it be? If it is moving through zinc, how will it be? Each and every element is not going to have the same velocity, isn't it? Like each and every material is different. So they started doing material science studies where they tried to understand how does my velocity change in different materials. Based on that only, they finally divided the earth into several layers, and they also gave different compositional mechanisms also. So currently, okay, if you take the earth, in NCRT's description, we have three broad layers. And this is after velocity studies. How does your velocity seismic waves change through different materials? We know that like there are certain points where velocity change is very drastic. That is considered as the demarcated portions. So the first topmost section is called the crust. This is the biscuit which we are talking about, the biscuit where we live on. Second layer is called the mantle, M-A-N-T-L-E. Third layer is called the core. It's the core which has different divisions. The outer core is liquid. Outer core is liquid. Let me write it here. Outer core is liquid medium, and the inner core is solid medium. Like this is what we were trying to explain. Inner core is solid, right? Mantle is again solid medium, crust is solid medium. Here there is no doubt. Solid, this is solid. So based on velocity studies, you see it is given in NCRT, and I just want you to know that currently the composition has become more and more complex. See, at the start you would think that only 2 or 3 materials is the largest composition, but now it is becoming more detailed where even micro elements are trying to be identified. But if you take the largest composition, this is it. Crust is primarily made of silica and aluminum. Silica, aluminum. In this case, silica, magnesium, mantle, magnesium. Okay. You take the core. Core is primarily made of nickel and iron. These are heavy metals, right? Nickel and iron. Is it fine? So what is there in the center is predominantly iron. Hard core. See, iron is the heaviest element which you get using during a supernova explosion. So until then, your supernova, your star is able to fuse your hydrogen and helium. Beyond that, it usually runs out of power. Okay. Now, in this entire segment, a very important layer is missing, and that is what I'm going to add at the last. Of crust, mantle, and core, we are concerned about a small portion of mantle which is present at the top. It is called the asthenosphere. It is present here, right there. Below the crust, top portion of mantle. Top portion of mantle, this segment. This is called the asthenosphere. Asthenosphere. Okay. Top portion of mantle. So we need two explanations right now. First is, what is this asthenosphere? What exactly is that? And second question which you should get is, why is there a variation between the solid core and the liquid core? Like, why should there be a variation? Okay, so two reasoning factors are done. If those two reasoning questions are answered, your interior topic is over. Okay, like then if you read the text, it'll be much comfortable for you to move ahead. Okay, so let me start with the first question, like what exactly is this asthenosphere? Number one, I do not know whether the mistake is done in NCRT, but anywhere, if you come across a statement stating that asthenosphere is the molten material, no, it's not molten. Okay, I'll give you the exact word. That's the way it is to be written. Asthenosphere is the solid ductile medium immediately below the crust. Immediately below the crust. Solid ductile medium. Now, to understand this meaning, I'll have to take you to some totally different topic. Again, you will think it is not relevant. It is relevant, very relevant. Okay. See, assume that I go to Government of India. I tell them that I'm a very important nuclear researcher. First, they would not believe me, but still, assume like I'm the. Just think that Government of India accepts that I'm a big nuclear scientist. I ask them for maybe a small ball of uranium which looks like dairy milk shots or something. I go and ask them, enriched uranium, 97%. Government of India says, fine, Thambi. Thambi means small boy. You can take this uranium. I come to you. Okay, I open your shirt pocket, put it inside the shirt pockets. Okay. When I put it inside the shirt pocket, you know what will happen? You'll die of cancer. Don't worry, I won't do that. First, Government of India won't give me that uranium. The point is, once I drop that uranium inside your pockets, okay, first of all, before you get skin cancer and die, first your pocket will burn. You know why? Because uranium is radioactive. First, let's understand radioactivity. Radioactivity. See, hydrogen is a wonderful element. Okay, it's made of only one single proton and one single electron. Very stable, very, very stable. See, whenever the number of protons and electrons begin to increase in an atom, any element, okay, that is when it becomes unstable. You take uranium on the other hand, you compare it with hydrogen, incomparable. Uranium's atomic number is 92 and its mass number is either 235 or 238. It's a very, very heavy element. Once the element becomes heavy, you try to assemble too many protons, too many neutrons, and too many electrons together, it is not in a stable state. So anything in nature, okay, just like human beings, we try to settle in life, right? So every element moves from an unstable condition. Forget hydrogen for now. Hydrogen was written for simplicity. It's an elegant element. It's very, very elegant. Unstable to stable state. Every system tries to achieve stability, correct? So this unstable uranium tries to reach stability. Now think about this. If I have too many electrons, too many protons, and too many neutrons, I want to reach stability, then I automatically radiate energy. I do not want these extra baggage. This process is called radioactivity. So uranium radiates large amount of energy. This is called radioactivity. So through this process of radioactive decay, so along this, it will release alpha particles, beta particles, gamma radiation. Gamma radiation is what is capable of causing skin cancer. Very, very powerful if you look at it. Very short electromagnetic radiation. This process is called radioactive decay, where an unstable element becomes a stable element. Now let's come back to this question again. So if I take uranium and put it inside your shirt, why does your shirt burn and create a hole? Because uranium is releasing large amount of energy. So that is why your shirt is getting burned. Now visualize this. We'll take uranium, okay, and place it over a rock. Or let's take two to three different rocks. You place uranium in the center and then close the rocks. Uranium will continue to radiate energy. So whatever is surrounding uranium, okay, as uranium consistently radiates alpha, beta, and gamma particles, these materials will get heated, right? Once you get heated, slowly you get modified. Slowly but steadily, very, very slow process, okay? Because increase in temperature, your atomic structure will slowly get broken down. You'll automatically begin to adjust yourself. This is what is happening in the asthenosphere. Because asthenosphere has a good concentration of radioactive materials. Meaning makes sense. See, all your volcanic eruptions, earthquakes, and tsunamis, mountain building, these processes are not related to the core. No, it's not because of this. It's because of this. You have a good concentration of uranium here. And since uranium is radioactive, it is constantly modifying the sphere. Now let's read the meaning of this word. Look at the statement. Asthenosphere is the solid, it is solid, ductile medium. Now, in physics, ductility is a process, is a word used to explain the phenomenon of property of metals to be drawn into sheets. Okay, like that is, to be drawn into wires. So ductility simply means it is a solid medium, but it can be modified. Okay, where does the modification come from? The modification comes from radioactive heat. So radioactive heat slowly modifies this medium, constant modification. And this constant modification is what leads to volcanoes, earthquakes, and formation of mountains. Meaning makes sense. So let me write the statement here. Yeah. The asthenosphere is ductile, and is constantly modified. Due to radioactive heat. From unstable elements. Full stop. Okay. So first question is done. Okay, we need to understand the second one. Like, why is there a difference between solid and liquid? Okay. Quite lucky we got, isn't it? See, if you do not have those radioactive materials, there is no volcanoes, there are no earthquakes. Okay, there is no mountain building. Life would have been totally different. So many things had to fall in place to create what is called as Earth. Okay, and we get to live something called as life. Fascinating, is it not? Coming to the second question. This will be a simpler question, don't worry. Solid liquid transition, no? This is you lying down. This is also you lying down. Condition 1, condition 2. First condition, I am not placing anything on you. I am asking you to get up. Second condition, I am taking this chair. I am placing this chair over you. Now asking you to get up. Okay, you tell me, condition 1 and 2, where will you get up easily? 1 or 2? Any Mahavirans there? One person is there. 2 on 2. I will definitely do that. Is it clear? You can't do it because a weight is placed over you. Here there is nothing over you. You can automatically get up. As simple as that. See, this principle can be applied in physics to understand something very complex. Boiling point. Okay, see. This is bowl. In bowl, water. Water heated. This is bowl. This is water. Water heated. But let me say I put enormous amount of pressure. Pressure is nothing but weight, no? Okay. The thing is, boiling is nothing but you're trying to convert liquid to gaseous state. That's all, no? Now see, there is no one on top. No one is disturbing you. Once you start heating, boiling point of water is 100 degrees Celsius. 100 degrees Celsius, automatically water will evaporate. Because no one is there to disturb you, you will get up. Come here. 100 degrees Celsius you heat. Water won't evaporate. Why? Weight is placed, isn't it? This is the principle of pressure cooker. If you start to increase the pressure, exactly at 100 degrees Celsius, your water is not going to boil because weight is placed over you, can't get up. You need to put more heat, 105, 110, 120. You keep on increasing the temperature, only then I'll have enough ability to break open this pressure, then get up. That is only Mahaviran. Mahaviran, non-Tamil speakers, Mahaviran means Mahaviran. Brave, big warrior. Okay, that is only that person. Now, the point which I'm trying to convey is this. With increase in pressure, the boiling point and melting point will increase. will increase. You might be thinking, where did this melting point come from? Melting point also same principle only. We'll be in a position to maintain the atomic structure. Okay, if you increase pressure. Mahaviran means Bahubali. Yes, correct. Correct. Bahubali is a very good reference. I'm pretty sure Prabhas thinks he is actually Bahubali in real life. See, once you start to act in a movie like that, okay, where you can lift things and the entire statue and all holding with one rope, means person will begin to think. 5 years he is acting in the movie. Okay, coming back to the discussion again. How is this actually relevant? See, this is relevant to understand the core structure. Let me take you to the core structure again. See what happens. Core, but there is a difference between interior, outer core, inner core. This is my mantle, this is my crust. Something fundamental here. Question for you. Let's see whether you can answer. If you answer this question, you'll be in a position to get this link clearly. Why is any answer, like this is not a yes or no answer. Why is iron concentrated more in the core? I'll repeat again. Why is iron concentrated more in the core? Why? Simple question. Simple answer. Very good. More denser. See, iron is a heavy element. If a heavy element is there, heavy element will automatically sink down. It's as easy as that. Right? So since iron is heavy, it is able to sink to the core. You take lighter elements, you take silica. Silica is a very light element, it is able to float and then form the part of the crust, part of the mantle. Iron is dense and sink to the bottom. Now, you need to apply one more thing. Listen carefully. If iron can sink, uranium can sink. Right? Because uranium is even heavier. See, please understand, a large concentration of uranium is actually present in the interior of the core. Meaning makes sense because uranium is a very, very heavy metal. Radioactive elements, you take uranium, plutonium and all that, it's present more in the core because it's much, much heavy. Listen carefully. Radioactive materials are there. Write that. Radioactive materials are there. Radioactive materials in the core. If radioactive materials are present in the core, there is constant heat. We just pictured it right now in the astrosphere. Constant heat and temperature will naturally melt the surroundings. There is no doubt at all. But in spite of that, your inner core escapes because of one small difference. See what happens? Crust, mantle, and core. Look at the weight placed over here. Inner core is there. Look at the amount of weight. It experiences very, very high amount of weight, which is nothing but high pressure. Just now we saw, if you increase pressure, melting point will increase. Correct? Melting point. If melting point is going to increase, what is the meaning? See, melting point is a state in which solid state will get converted to liquid state. So let's say that iron melts around 250 degrees Celsius. If you increase the melting point, iron is not going to melt at 250. You make it 300, 350. So iron will retain its solid state. I will be there in solid state itself. Because you only provided pressure. Once you increase pressure, you increase my melting point. I won't melt at 250. You need to increase temperature even more. I will happily say 350 degrees Celsius, 400 degrees Celsius. You are not able to heat, it will remain in solid state. You take outer core, look at the weight. Get the idea? Compared to inner core, outer core is experiencing less pressure, correct? Pressure is less. Melting point is less. Once melting point is less, it's like remaining at 250 itself. It doesn't become 230. That's not the meaning. It's there in 250 itself. Now it will easily melt. Once this is melting, this will become liquid. That's all. So simply a question of pressure. Don't forget these columns. More pressure, more melting point, continue to remain in solid. Less pressure, less melting point, which means easily melted. Solid becomes liquid. As simple as that. Okay. gravitation and more weight due to pressure, heat. Right. Does Earth's core affect Earth's geomagnetic field? Yes, we will understand geomagnetism later. Like after continental drift theory, we'll understand that. Okay. But sir, this is possible by rotation of the Earth. Yes, let the Earth rotate, no problem. Hey, take egg, rotate egg. Egg rotates, no, in spite of the fact that liquid is there inside the egg. It can rotate, no problem. You take sun gas rotates. Jupiter, gas rotates, no problem. You're talking about immense celestial bodies. Is it clear? Why is it usually said a vessel gets easily heated when closed with a lid? You are correct. Vessel gets heated. No one talks about boiling point here. Okay, you're not allowing heat to escape. You're right. Is it fine? So shall we move on to the next one? Let me know whether you've taken this. Use the word finish. I'll move on. I expected. Okay. See, before the break, I have to give you a break right now. Before this, you better answer this question. Later, you will ask me, or 15 days later, you'll ask me. Now, you answer now itself. என்ன சொன்னேன்? நான் என்ன சொன்னேன் means, what did I say? Heavy metal will come down. Uranium coming down. Correct? How uranium here? How? Explain. 30 seconds time. Everything should come down. Then how? Uranium heavy metal na come inside. Radiation. Summa one word, radiation. What radiation? Let's. No. Constantly modify. Naane solreenga. Leave it. I will explain. I'll explain this and give you a break. I will tell you my story about cooking. It will take only 2 minutes, but it will be essential for understanding this. Okay, after that, I'll definitely give you 5 minutes break. See, once you start, start living alone, okay, you will try your attempt at cooking at times. Okay, I also tried. Fine, I got a cooker, I tried. Thing is, I'm not technically a cook. I only know to boil things. I'm more of a boiler, not a chef, but a chef. So, thing is, I try to do noodles. 6 months or 7 months, you try to cook noodles. That's the most easiest thing. No? Noodles, nothing you'll have to do. Mother started scolding. Noodles, if you cook for 6 to 7 months, you can't constantly eat every day. You will die out of stomach cancer. She said, how do you cook noodles? I told, simple method. Take bowl. Okay, it's a very procedural, structural complications to be very proper. Take bowl. Okay, put few drops of oil. Okay, some sliced onion, 1 cut chili. Okay, then after that, keep sauteing for 90 seconds until it becomes golden roasted color onion. 2 glasses of water. Then 2 packets of Maggi noodles, masala, close. After 11.5 minutes, it will be ready as noodles. She said, there is one more dish called upma. Very simple, same procedure. Okay. Thing is, it is not simple. She said, you try this, same procedure. I was like, fine. Today I will get graduation in cooking. From school child, I'm going to become graduate. I was like, take bowl, oil, okay, all that onions, chili, keep sauteing for 90 seconds, 2 glasses of water. Then already upma, which was heated up in, closed it. One important principle I forgot. In noodles, in the masala packet itself, salt will be there. You put masala in, automatically it's done. Upma, you need to add salts. I completely forgot. Okay, thing is, I kept it heating, almost boiled. 6 to 7 minutes gone. Solidification process almost complete. This is what happened. Bowl was there. Almost getting solidified. That day I did not have that powder salt also. Only iodine crystal salt will be there. Only that salt I did. I used all my force. Opened, took some crystal salt. Tried to drop in upma. Solidification process started. So what happened is, most of the crystals due to the force went inside. And they stayed in one place. That is different. Some crystals, in spite of the force I given, they got trapped here itself. You get the idea? This is the worst upma I ever eaten. After that, I stopped cooking. Point is, you take the earth. Naturally, heavy elements will sink to the bottom. Meaning makes sense. But even if an element is heavy, if the Earth's crust has already started solidification, if you remember, the cooling process of the Earth started outside in. Like evolution of the atmosphere you would have seen, starting origin of the universe. Outside is the first process which is actually cooling. So when it started cooling, some amount of uranium, some amount, got trapped here. Even today, most of the uranium is actually in the core. Because of this only, you have the asthenosphere. Don't write this in exam. This is for understanding. If you got the idea, this is the most important point. Earth's solidification process was outside in. Because of that, some amount of uranium got trapped in the asthenosphere. Is it clear? Take a break for 5 minutes. When we come back, we enter theory of continental drift. Before that, formation of fossil fuels. 5 minutes. Upma is a dangerous dish. There's one statement and it's right actually. Uh, like this is how we also have iron on the surface. Exactly, right? Like if you're right, like if it's only about heavy metals, then all the heavy metals should only be exactly in the interior, and you shouldn't find any metal at all, right? There should not be any cobalts, no copper, no nickel. So usually metals sink down, and that's similarly applicable to iron and every other metal which is present in the surface. So now the continuation part will be formation of fossil fuels and then continental drift theory. Pretty sure formation of fossil fuels can be done, CDT can be done, then we will see based on time. At least basic of geomagnetism I'll try to give you today. Okay. Formation of fossil fuels. See, this is a necessary topic for continuing the next one. That's why we are addressing this right now. Formation of fossil fuels. See, we are talking about the most basic things. We're talking about formation of coal, oil, natural gas, bitumen, heavy oil, whatsoever. Like anything you want to form. Natural gas hydrate. Fine, natural gas hydrate, like anything you want to form, you need a certain set of conditions. First is mass murder. You need large number of living organisms, right? So visualize a large number of living organisms. So let's say there is a forest area which is closer to the coast. Okay, the first is large number of living organisms. Living organisms dead, all dead. Maybe let's say there is a tsunami, there is a volcanic eruption, anything. We are talking about a very large scale disaster. And this disaster, okay, destroys them, all of them. So all of them are dead. And the plants lie down. They are uprooted. Maybe the volcanic eruption spreads over large amount of ash and all the materials are lying down. Okay. See, in this process, the second point is very important. It's not about a disaster killing large number of plants or animals. That's quite normal if you take Earth's history. Earth has been very unkind to several species which walked over this. Actually, close to 85 to 90% of all the species which were on the Earth were destroyed at one point of time. Okay, because there is constant generation, at the same time constant destruction of organisms. It's very normal. Second point is, over these dead organisms, you want to make sure there is good amount of sedimental deposition to prevent their contact with oxygen. Fine, let me write that and then explain. Okay. Over them, thick deposition of sediments, to prevent contact with oxygen. Prevent contact with oxygen. And this sedimental deposition, I'm not saying instantly. Like the disaster is there, someone comes up with a pail of sand, and not pail of sand, maybe a bucket of sand and pours all over the sand, pours the sand all over the dead organisms. No, that's not what I mean. Thing is, if the disaster is done, okay, and slowly, let's say there is a constant lapping of the shores. Maybe there is still volcanic ash which is getting spewed over a very large area. Very slowly, the sediments is completely covering the dead organisms. That is what we mean. It's not talking about instant. Nothing happens in nature instantly. It takes some time. Now, let's understand the meaning why you need to prevent contact with oxygen. Okay, because oxygen is a very good decomposer. Follow up here. Okay, decomposition is going to happen, but you don't want oxygen. Why? Look at the meaning of this word. Compose means complex. Decompose is try to break down into simpler substances. Your objective is to form coal and petrol, correct? Coal, oil, natural gas. Now, if your decomposition is very, very fast, if it's accelerated, all the complex materials will break down into simpler substances. If simpler substances are created, you cannot store energy. You take coal and oil has enormous amount of energy. You use them as some sort of source, it provides you with lot of calorific value. If your oxygen is present, oxygen is a wonderful decomposer. Okay, very, very good. Like without oxygen, several organisms will not have that ability to do it. That is why you do not want oxygen's decomposition process. It will accelerate the process. It will break things down. If it breaks things down, you will not store energy. You want a decomposition process, but at the same time, energy should be stored. Only then you will form coal and oil. Now visualize this. If you're preventing contact with oxygen, does that mean decomposition won't happen? No, decomposition will happen. But decomposition will not have oxygen. The process is called anaerobic decomposition. anaerobic decomposition. So you do not want oxygen. In the absence of oxygen, anaerobic decomposition will take place. This will make things complex. It converts your biomass, your animals and plants into very, very complex substances of hydrocarbons. You don't want oxygen at all. Now, most important thing, okay, I've already told you sediments are deposited, which means there is good amount of pressure. Due to sediments, there is good amount of pressure, right? Now, along with this, the most important parameter, if you want good quality coal and oil, give it enough time. You will form fossil fuels. So all these four conditions go together, then you will form oil and natural gas. Now we need to understand the difference for one more conceptual clarity. Okay, like the basic difference between coal and oil. I'll read these again, then I'll proceed to the next slide. Over the dead organisms, thick deposits of sediments to prevent contact with oxygen that will lead to anaerobic decomposition, which will form coal and oil. Now this is properly facilitated by sediments, which add a good amount of pressure. You're compacting. At the same time, most important thing is time. You don't form this in a year or 10 years. You need millions of years. You provide them, then naturally you will get coal and oil. Now let's get the difference between coal and oil. What is coal? When do you get coal? When do you get oil and natural gas? Simple. See, if the dead organisms are predominantly plants, you will get coal. If the dead organisms are predominantly animals, you will get oil and natural gas. Here also you need clarity. Okay, I'll just ask a simple question. You think of yourself. Okay, think within yourself. The thing is, if I ask you a question, have you seen a large number of plants together, you will tell me, yes, I do know a large number of plants. This is called a forest area. So forest area, if you're going to kill an area and then compress all your forest, you will get coal, no problem. Have you seen large number of animals together? Don't tell me forest. If you say forest again, even if 100 dinosaurs were there, 100 dinosaurs don't hug each other and die. Come, we will die together. No, it doesn't happen. Fine. You're talking about animals where you do not want domination of plants. Now, where does this happen? We are not talking about terrestrial animals. We are talking about marine animals. Okay. We're talking about water. These animals are zooplanktons. Zooplanktons. And zooplanktons are present in water. So some clarity. Plankton means Plankton. Plankton means free floating organism. Any free floating small organism, that's called a plankton. When I say zooplankton means it's an animal, that's all. You use the word zoo to indicate it's an animal, zooplankton. So idea is this. Look at this interesting part. If you need oil and natural gas, you need animals. The animals are zooplanktons. The zooplanktons live in water, which means if you need oil and natural gas, you will need water. Without water, you cannot form oil and natural gas because the organisms live in water. You got the link? Fine. Now let me ask you this question. I know one place called Saudi Arabia. In Saudi Arabia, oil is there. Where is water? Answer. There is water in Saudi Arabia. Yeah, very good answer. It was there. When? Long ago, so long ago, no one remembers. See, let's cut that. See, the point is, larger portion of Saudi Arabia was actually underwater. Fine, you take your Arabian Peninsula. Arabian Peninsula was not technically connected to your Eurasia, actually. Arabian Peninsula was slightly off, and certain sections were submerged under sea. You take India, for example, you take Rajasthan. Rajasthan has good amount of oil and natural gas. Gujarat has oil and natural gas, but both Rajasthan and Gujarat actually, they're present on land, they're not underwater. This used to be like this. You had Kutch Peninsula separately, Kathiawar Peninsula separately. They are not even properly connected to India. And parts of Rajasthan were actually submerged under sea. As seawater receded, this becomes one integrated unit. Today, you look at oil and natural gas reserve, like equivalent to Maharashtra, you'll find a good percentage in Gujarat also. At the same time, you will find it in Rajasthan also. Assam, another story. Assam is a different story. That is also like you had a good percentage. Assam Ridge was there before India went and collided with Eurasia. So always remember, if you do not have water right now, possibly several million years earlier, that section would have been under sea. And that is the reason you formed oil and natural gas. Got it? Now, why did we spend time all of a sudden? Why did we take a turn instead of going to continental drift theory? Well, the reason is we are going to discuss about something which was not possible to explain very easily. Here we are talking about 1900 to 1910, where oil and natural gas reserves is explored across the world. Think about this high level of colonization, industrialization. Like Africa was colonized by 1900 and World War is in 1914. I think you get the timeline, please. So 1900 to 1910, people are exploring oil and natural gas reserves. There was one problem. Scientists were not able to explain an anomaly. There was rich oil and natural gas in the Russian Empire. Back then, Russia was an empire. Siberia. Fine. You were not able to explain because there is a problem. So if I say that Siberia was under sea, Siberia had large amount of water body, and because of that you had oil and natural gas, it does not really help them because Siberia is not an equatorial region, correct? Siberia is very, very far away. It's like in 65 degrees, 70 degrees. 65 degrees, 70 degree latitude, you don't have large number of animals. Population is very, very less. Picture a coniferous forest. Coniferous forest, the trees are widely spaced out. Okay, you cannot form a large amount of oil and natural gas if you cannot have good amount of biodiversity. Okay, need, if not biodiversity, population. Population is always more in tropical climates. You take population, population is very less here. So how do you explain the presence of oil and natural gas in Siberia? Two ways are there. I'll put two ways. You tell me which is the better one. So simply saying water won't cut because Siberia is having less population. Now, two other ways are there. First is this. Sir, several million years ago, several million, that's all, several million years ago, Siberia experienced climatic conditions of very, very high temperature and high rainfall. Very high temperature and very high rainfall. Because of that, there was high population of animals, zooplanktons. When these zooplanktons died, there was formation of oil and natural gas. Several million years later, this latitudinal climate shifted from 60-65 degree latitude to equator. That is why today we have very high temperature, very, very high rainfall in equator. Feasible, right? So I'm saying that high temperature and high rainfall was in Siberia that created good population, good oil and natural gas. So now it is there in equator. This is one method of explaining. In this, land I have placed constant. Land is constant. But latitudinal climate is changing. Latitudinal climate is changing. There is one more method. Listen to this, then you take it down. One more method is this. Sir, several million years ago, Siberia was here. In this region, there is very high temperature and very high rainfall. Because of extremely high temperature and rainfall, there were large population of zooplanktons which got converted to oil and natural gas. Currently, Siberia is here. Feasible. Okay. Here, latitudinal climate is constant. Land is moving. You get it? Land is changing. You are a geographer, a German geographer. You are conducting a conference in 1912. You are inviting people from all over the world, the leading 100 or 150 geographers. Your rivals are there. You have people coming from Britain, people coming from Americans. You really don't like them. Germans never really liked, even in the academic field. Now, let's say you want to support a theory. Okay. Let's say, really say that you want to take one theory and then properly explain the theory. This is one way of explaining. Second way of explaining. Got it? Now you tell me which is easy to explain, which is easy to defend when all your enemies are there. First or second? Yeah, it's actually second. See, thing is, if you say this now, they'll ask too many questions. They will ask, oh, you are saying that Earth was like this, then Earth went like this, then Earth went like this because of the equatorial climate. This explain means we cannot explain that. You take this, this is very, very simple. I automatically change jigsaw puzzle. Climate is very complicated. Okay, Hadley cell went here, Ferrel cell went here. Why that problem? Land moved, sir. Because of land movement, you had oil and natural gas. That's it. So one individual in the year 1912 went ahead with this theory. Okay, he's a German geographer who goes by the name Alfred Wegener. Is it clear? In 1912, German Alfred Wegener introduced a new idea, introduced a new, I'll use the word thesis, new thesis, that land is not constant, land is not constantly fixed in a place, but moves. He floated the theory of continental drift. Theory of continental drift. Full stop. Why can't we find oil in Himalayas? It's also uprised from Tethys Sea. See, thing is, it's okay. The right way to understand is you will have sediments, but when it comes to Himalayan region, it's more about exploring the process. Himalaya is a very complexly folded mountain. Even if you find oil and natural gas, it's extremely difficult to explore. 5 sets of mountains are there. You have, see, look at you. I have Sivaliks, Dauladhar, Pirpanjal, Zaskar, every layer. It's very complex. So that's the Himalaya is very unproductive in terms of minerals. For example, in Jammu and Kashmir, we have anthracite. The best coal in India is actually in Jammu and Kashmir. It's a very, very small, narrow. But Kashmir, there are several problems of political issues. So in that situation, you cannot go for economic exploration. Same thing with Sikkim and Arunachal Pradesh also. So even if minerals are present in Himalayas, it is not in an extractable form. It's complex folded mountains. It's very difficult to explore them and extract them. Okay, but if you simply ask, are there resources in Himalayas? Definitely, it is there, but difficult to explore. Moving on. So you need to understand it this way, like how exactly the theory is presented 100 years, 110 years earlier. So when you present it, you're not doing it in form of presentation. Back then, they used to have elaborate paintings and the theory is presented and it's supported with proper evidences. So Wegener comes up with this bizarre recommendation. See, no one ever thought of this. His theory starts like this. He proposes that all landmasses in the world, all landmasses of the world, where one single continent called the Pangaea, surrounded by the ocean, Panthalassa. So I told you, bizarre statement. No one ever tried stating these things. Maybe they did not have the guts, but this person said, you just had one single continent. That's it. Everything was together. Pangaea, Panthalassa is the ocean. And this was during the Carboniferous time period. Okay. So what exactly is this Carboniferous? I'll give you a snippet idea. Okay, like in detail, it is not required. See, just like you classify the number of months in a year as January, February, March, April till December, you take Earth's geological time scale. It is classified into different eras, different epochs. So Carboniferous is one time. Maybe you can take it like April month, something like that. Also, he says that all the continents were together in the month of April. So you take Earth's geological time scale, it is, he says like at this particular point of time, everything was together. Okay, see what happens. He says, once he said this theory, people started criticizing immediately. This is more of a blatant statement. You cannot come to a conference and then state that I assume like this is what happened. If you want to go for such a bizarre assumption, you support them with evidence. Then Wegener stops and says, fine, let me provide you proper evidences. And then using the evidences, we'll see how continents evolve. So evidences. So how do you come to this conclusion? Point one. Okay. The continents could be fit like pieces in a puzzle. Pieces in a puzzle. Example, Africa and South America. Africa and South America. When you were drawing this, you would have definitely understood that. So if you draw Africa and then you draw a portion of South America, okay, one way or the other, okay, both of them can actually be joined as a single continent. You can do that. Fine. So this was one of the important evidences. He said, see, like superficially, if you look at this, this seems to be made of the same material because the coastline of Africa and South America seems similar. Is it clear? Tectonic plate. Tectonic plate I haven't taught. Tectonic plate you will understand under plate tectonics theory. That's the next theory. This is the first one. Please wait for it. If the earthquakes happen at the Arctic, will S waves travel to all longitudes? Prakash, earthquakes at Arctic is kind of not possible because Arctic is an ocean. Arctic is an ocean. Antarctic is okay. Antarctic, yes. Antarctic is land. Arctic is an ocean. So there you don't have plates. Please wait for plate tectonics. I think you'll understand that clearly. So this is a first reasonable assumption. He says, see, if I take two pieces and I can fit them together, then it actually means both these pieces were connected even earlier. Only now they are separate. Number two is much better. Okay. The geological structure was similar in the northeastern USA, northeastern North America, northeastern North America. So we are talking about Appalachian Mountains. I think you remember Appalachians. Appalam and Appalachian Mountains, map reading, right? Appalachian Mountains and Western Europe. Scandinavia. Now you should be very similar with Scandinavia too. Scandinavian mountains. So based on rock structure, he stated that, see, these two regions are very far away. For example, take North America and he discussed about Europe. Okay, Scandinavia is here, right? Okay, and Appalachian Mountains are here. But both these mountain ranges have similarity in rock structure. So 1 and 2 have very close relationship. It actually indicates that these two mountains might have been together. Like both of them were created out of the same material. So this indicates that North America and Europe were again together. So first one is for Africa, South America. Second is for North America, Eurasia. Is it clear? Use the word finished if you're ready. Point 2. Okay, one question. Is there a good possibility to find oil and natural gas in every ocean bed? Yes, very good possibility. Number 3. Thanks for responses. Third one. See, third is about glacial deposits. See, if you have two land areas, and let's say both the land areas have a glacier, okay, and the glacier melts and deposits over this region, or the land area separates and the glacier is retained, like the deposits in both these regions will be same, okay, because glacier was technically connecting these two lands. This is one way of interpretation. So based on glacier deposits, he gave this idea. The glacial deposits, in NCERT, they would have given it as tillite. Glacial deposits called tillite had similarity in the western coast of Africa western coast of Africa and the eastern part of Brazil. Oh, this is Brazil. Fine. So again, western part of East Brazil and West Africa technically connected. You know, we just saw it as the first evidence, but first evidence was more superficial. We're just talking about the coastline, but this is more related to your rock structure and all that. Is it fine? Number 4 is an important evidence. Okay. Fossil distribution. Fossil distribution was a strong evidence in support of this theory. Strong evidence in support of this theory. You will need a diagram for this. Okay, hold on a second. Just a second. Right. What type of fossil distribution are we talking about? See, fossils, you get the ideas, and we are talking about dead organisms, dead plants and animals. And that's a very strong evidence. He was specifically talking about one plant fossil and one reptile fossil. And these fossils were located along different continents. It was not in one. Take this diagram down. See, when I ask you to draw this diagram, please don't draw these things and all. Like this. Don't draw these things. That is not required. The outline of the continents, that alone. Just the outline. South America, Africa, India, Antarctica, and Australia. Just the outline. Try drawing. Spanjagond Kumari Kandam in Tamil. Karthik, I'll let you know this. Every class I get this question. There is nothing called as Kumari Kandam. Kumari Kandam does not exist. We do not have any scientific geological evidence for supporting the theory of Kumari Kandam. If it was there, you would have discovered it at least by now. It's not scientific. It was more to do with politics. Okay. Lemurs found in Madagascar and Nilgiri ranges. Yes, they were related. Of course, Madagascar is related to India. You will learn that in plate tectonics. But Kumari Kandam does not exist. We don't have any evidence for that. So it was only for a political movement in 1960s. They had to get this mileage in Tamil Nadu. So that's why it was used. When I explain plate tectonics, you'll get even better idea. Kumari Kandam technically cannot exist. It's not possible. Define. Okay, saying in relation with fossils. Gobi, lemurs are living organisms. They don't become fossils. Lemurs. See, the thing is, if you take this plant, I will give the name later, or I'll write the name first. Hold on, let me write it here itself. Glossopteris. Glossopteris. Cyanognathus. C-Y-N-A-N-O-G, right? Yeah, N-O-G. N-A-T-H-U-S. Glossopteris is a plant fossil and Cyanognathus is an animal fossil. See, the thing is, if you take this plant, you can just draw lines connecting all these parts. This one. It is impossible for the plant to jump from one continent to the other. It's not possible for the plant to do that. Only explanation is when all the continents were together. Okay, it was maybe true that the plant, using its method of seed dispersal, was present in all those continents. Later, the continents got divided and then broke apart, separate ways. That is the only explanation. Same thing can be said for Cyanognathus too, the reptile which was present in South America and Africa. So this is the only explanation. All were together. It's like 5 members of the family stay, the land breaks down and all the 5 members get separated individually. Okay, this was a strong evidence. So once you have given the evidences, people were fine. Okay, fine. Let's look at the theory right now. So we are going to continue from where we left with Pangaea. Ready? So now to continue with the theory. The supercontinent of Pangaea. You copied the diagram. No, I assume you copied the diagram. You should have, I think so. Okay. supercontinent of Pangaea broke down. People, did you copy or not? Wait, let me ask. No response. Copied. Okay, fine, fine. This is the problem with online session. Broke into a northern Laurasia and a southern Gondwana, separated by the Tethys Sea. So now the continents are going to break down two large parts. So here one circle becomes a semicircle, two semicircles. So Laurasia and Gondwana. What you have in your notebook is Gondwana. The 5 continents were there, isn't it? India, Africa, Antarctica, Australia, that is Gondwana. Northern part was made of North America and Eurasia. Okay, Laurasia and Gondwana. So in between them, you have this Tethys Sea, separated by the Tethys Sea. Fine. So he said, once the two continents are broken down, the two continents experienced two different types of movement. One was a movement towards the equator, and the second was movement towards the westward side. And both these movements were governed by different sets of forces. Fine, so I'm going to write that on the board again. I'll read this, then I'll write it on the board. The supercontinent of Pangaea broke into a northern Laurasia and a southern Gondwana, separated by the Tethys Sea. So next statement, the continents experienced equatorward movement governed by differential gravitational force DGF, okay, and force of buoyancy called FOB. Same time there was, so equatorward movement is one, next is westward movement. I will explain, hold on. Westward movement, okay, governed by tidal force of the moon. It's clear. Yeah, I will send the slides. No, 4th point slide once again. See, we'll need to get the meaning of these statements, isn't it? Like, what do you mean by DGF, FOB, and then the tidal force of the moon? See, it's about which force is going to govern which type of movement. Like the results we will see in the next slide. But before going to the next slide, we'll get an idea of what these are. First, this word, force of buoyancy. See, buoyancy is the force which enables an object to float properly. That is, let's say you take your mug and force your mug inside water. Okay, you will face a good amount of resistance which pushes the plastic mug back again, right? Force of buoyancy is exploited by ships. Think about the ships are made of iron and steel. So based on their density, they should technically be sinking inside water. But that doesn't happen because they use the buoyant force properly. The hull is designed in such a way that the ballast water which is held on to both sides are able to properly hold on and maintain stability of the ship. So that is buoyancy. Buoyancy allows an object to float properly. Is it clear? Differential gravitational force, as the word states, is basically gravitational attraction, okay, on account of mass. Your gravitational attraction on account of mass, DGF, differential gravitational force. Fine. And coming to the last one, I think this is self-explanatory. We are not talking about forces which are present on the earth, but rather tidal force of the moon. So we are considering moon as a celestial object, but we also say that moon has the potential to influence the earth. So we are talking about moon's gravitational force trying to influence the earth, certain parts of the earth to move westward. So this is about moon's gravity. Is it clear? So we'll go one by one how the continents are evolving. Ready? Yeah. Okay. See, after formation is northern Laurasia and Gondwana, the first movement was movement towards the equator. Equatorward movement, and you clearly know equatorward movement had force of buoyancy under operation. See, which means you can properly float without any resistance. This is when the crust is floating over mantle, the crust is floating over asthenosphere, that type of idea. Think back to the previous discussion. Crust is the top layer. So this is the top layer. Beneath that, you have the asthenosphere, the mantle portion. So the crust is floating over this region without experiencing any resistance. So now, due to differential gravitational force attraction, they are moving towards each other. So let's say they keep moving over millions of years. So two plates are there, two different continents. Two different continents are floating towards each other, and they're going to collide. Now, when they collided, an important event took place. Collision, not a proper circle. Looks more like this is okay. Collision led to the formation of east-west mountains. Okay, looks like a hamburger, but still east-west mountains. Collision. Example of east-west mountains: Himalayas. Himalayas. You take Alps. These are examples. Alps present in Italy. East-west mountains. Now, after this, certain parts of the continents also experienced fracture. Because if two different continents are colliding, it's not that they will maintain that stability. That is close to impossible. So certain parts got broke down. Okay, there was breakage here also. So after breakage during collision, this pink color line where I have drawn, where the breakage is present, these sections start to drift towards westward. Meaning makes sense. So this section, the northern section is in North America, southern section is in South America. So they're broken down and they're moving towards west. See what happens? The Earth, broken North America, drifting west. South America drifting west. Africa is here. Europe is here. We're not worried about it. They're drifting towards west. And who's actually drifting towards west, or who are making them move towards western side? It's the tidal force of moon. Tidal force is responsible. Pay attention to this, then you can copy. Like the content which you need to write is less. Okay, it's more about the understanding part. See? ஒரு நிமிஷம் இங்கே லெஃப்ட்ல வந்துடுங்களேன். இன்னும் கொஞ்சம். People listen. See, I am moon. I am moon. This is North America or South America. Is it clear? Now, I am trying to push this in this particular direction. If I try to push this in this particular direction, westward movement, I will face enormous amount of resistance. You know why? Because of the shape of the continent. We'll see how. Sriram, orange board living. Board orange. Fine. This is boat. Assume this is boat. This is the best boat I can draw. If you have a boat, I can push the boat forward, no problem. I can push the boat backward. There will not be much of resistance because the boat is designed in such a way that it's sharp in one area. Got it? Same boat, if I push it like this on the side, it'll be extremely difficult. There'll be more resistance. Is it not? Why I'm talking about this? Because you take both North and South America, they are triangular continents. North America has a wider top. Correct? Narrow base, triangle. South America has a wider top. Narrow base, triangle. Both of them have this boat-shaped structure. So North America is there, South America is there. You push it in this direction, you can, to an extent, you can push because shape of the continent. Very difficult to push North America towards western side, very difficult to push South America towards western side. Just like a boat. You got the idea? That's why you're talking about triangles right now. So now I'm trying to push North America and South America to western side. I will face more resistance. Fine. So see here. I am the moon, tidal force of the moon trying to push towards western side. Unable to push, unable to push. Now once I start pushing, see what happens to the Earth's crust. See, bottom portion is facing large amount of resistance. If the bottom is facing large amount of resistance, automatically the continent will capsize like this, isn't it? It'll come up. You get the idea? So crust which was technically flat until then, due to resistance at the bottom, it is getting capsized like that. Now why are we talking about this? This is what led to the formation of mountain ranges, Rockies and Andes. Is it clear? We'll see that how. See, straight பண்ணிடுறீங்களா? Board case முடிஞ்சு. Because of this movement, you had formation of north-south mountains. North-south mountains. North America, it is Rockies. South America, it is Andes. Okay, Rockies and Andes. And finally, you got to the original structure. Okay. Okay, CROC 2032535. I'll come to your question. Please hold. We'll have to address one major point before we take it up. So once they form a Rockies Mountains and Andes Mountains, because they face resistance. See, that is why, if you think about this, he would have given force of buoyancy here. Very good ability to float. That is why there is no resistance. You take this one, there is no FOB, there is no force of buoyancy in this westward movement. Got it? Let's move on. He presented as theory. Theory is presented. So this is how all the different parts of the world got segregated and then they reached their respective locations. That is my final theory. After he finished the theory, people, he was expecting people to clap. Something reverse happened. They thrashed him like anything. They said that you are unfit to be called as a geographer, you better go and die. Is it clear? It's a very sad story. We look at criticism first. Criticism. People are, before now itself I'll tell you, this theory is discarded. It is not applicable. It is a failed theory. Okay? Criticism. Criticism. Number one. The theory starts from Carboniferous period. Starts from Carboniferous period. And does not explain the events which preceded that. Does not explain the events which preceded that. See, it's like saying a person says on 21st of April, this is what happened. Before 21st of April, we have more than 100 days. You never spoke about that. See, Carboniferous is kind of a middle kind of stage. Before Carboniferous, you had several ages. For example, Cambrian, Ordovician, Silurian, Devonian, several eras were there. But he started his theory in Carboniferous period, which is not correct. He should have talked about the previous eras too. Number two, okay. The evidence of fitting of continents was not applicable to several islands. Was not applicable to several islands. Full stop. Okay. Not applicable to several islands. So that's why it asks you to wait. It's a failed theory. Several flaws are there. We'll just highlight few because we don't want to trash this thing. Is it clear? So any doubts are there, we'll take it up later. Let's finish this off. Evidence of fitting of continents is not applicable to several continents. Several islands I'm talking about it. Let's take Hawaiian Island, Andaman Nicobar, Madagascar. Larger continents you can fix, but what about smaller islands? Can't do it. Number three. The fossil evidences were sporadic to be considered as a consistent evidence Sporadic. Believe you understand the meaning of the word sporadic. Let's go back to the previous diagram again and get this idea. I'll read it once more. The fossil evidence were sporadic to be considered as a consistent evidence. See, the thing is, if you want to have a fossil evidence, okay, let's say that you get consistent, exploration. For example, let's say fossils are present in these locations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Consistently, if they spread over a large area, you can say that everything is connected, sir. Perfect. Wonderful evidence. But think about the year. Year is 1912. Back then, look at the level of technology. Only to an extent you can identify. So most of the evidences were like this. You had one here, one here, one here, one here. So they make an assumption then, which means the fossil is present in all these regions, like it is located in each and every section. That was the problem. If you need more consistency in finding evidences, you need more researchers, more people should try to excavate each and every area. Only then you'll find it. But you cannot have random points here, 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 just having 3 or 4 random points and saying that the fossil is present everywhere. That's why it kind of failed. But maybe if you have given enough time to Wegener, he would have explored, but time was not there. He present a theory. That's the problem. So it is way too sporadic. Sporadic meaning too random. You cannot consider it very seriously. Number 4. The reason for breakup of the supercontinent was not clearly stated. See, he said Pangea is going to break down into Laurasia and Gondwana. Why? He never said. He just said it breaks down. Number 5. Okay. The moon does not have enough gravitational pull. Moon does not have enough gravitational pull to modify the Earth. Modify the Earth's crust. Moon is a small body, very, very small celestial body. Moon can try to modify atmosphere, okay. Trying to modify hydrosphere, okay. Tides it is causing, okay. Land, how will it pull? Not possible at all. Moon is way too small. If Moon is such a large object, then Earth and Moon will go and collide with each other. That is not possible at all. Moon does not have enough gravitational pull to modify the Earth's crust. Fine. Point number 6. The theory does not explain several mountain ranges. Does not explain formation of several mountain ranges. Okay. Mountain ranges. Full stop. See, he was specific about Himalayas, okay? Alps, it's fine. To an extent, it's fine. Okay, talking about Rockies, okay. Andes, totally fine. No problem at all. But what about several others? What about Aravallis? What about Western Ghats? Okay, what about your Atlas Mountains? Several things went unexplained. Is it clear? See, these are just 6 points of criticism. You can have more. You can have even 8, 9 or 10. No issues at all. Okay, you find a flaw, you can automatically put that into picture. Fine. But for answer writing, I think you have enough content, because if you run through the slides, you have more than enough. Okay, starting from genesis of the theory, what is the proposal of the theory, what are the evidences, along with evidences, the diagram which you've already drawn, along with evidences that the theory, 2 different types of forces, movement, diagram for that. Then what is the criticism? So you have enough content, be it a critically analyzed question or an evaluate question, you have more than enough. Is it clear? So this ends the discussion here, and I'll just tell you something about Wegener. See, actually, Wegener was not disappointed, because he had his own geographers who were following in German. You had your rivals, they are the ones who are criticizing. So he went back, and this thesis was properly published as a book. It's in German, and I do not know German, so it's a pretty lengthy word, and this theory was actually published. Later, in one of the expeditions to the southern hemisphere, even though his assistants were there, okay, Alfred Wegener died as a lonely man, like in search of nature. Fine. But his theory will be accepted in a different way 50 years later. That is called as plate tectonic theory. Now, if I start with geomagnetism, we'll not have sufficient time to really wrap it up. I'll tell you the flow. Like next class, I'll try to wrap up geomorphology. It is quite possible, I think. It is possible. So thing is, we should be starting with geomagnetism, possibly next weekend. Geomagnetism. Based on geomagnetism, we have seafloor spreading. From seafloor spreading, we go to plate tectonics. Plate tectonics is the all-encompassing theory. This will answer all your questions. Why mountains in certain parts of the world? Why volcanoes in certain parts? Why Japan is more earthquake prone? All those questions. So once PT is done, your geomorphology is okay. Then we can enter oceans. Oceans will take 2.5 sessions, I believe so. Okay, so maybe like if we are very strict, I think 3 to 4 sessions we can definitely close geography, world geography. Then Indian geography will start. So possibly we'll meet next weekend. So any queries are there, please raise your hand. I'll ask him to enable. Slides I will send you, no problem. Like just like yesterday. Is it clear? So that's the end of today's session. So the remaining 15 minutes, I will take doubts. So others can leave. Thank you. Bye. Hand is enabled.
Good evening, sir.
Yes, go ahead.
Sir, may I know how many questions we can expect in geomorphology, sir?
Which one you're asking, ma'am? Prelims or mains?
Main, sir.
Mains, ma'am. When it comes to mains, sorry, 8 questions. Of these 8 questions, only 4 questions from static part of physical geography. So the 4 questions in physical geography in these 2 questions. So you can either maximum you can expect one question you can get.
Okay, sir. And prelims, sir?
Geomorphology last 7 years there is not even one question.
Okay, sir. For prelims, we can follow that 6th to 10th NCRT, no, sir, for geography.
Prelims, I think I've
Suppose
told
we want to wrap it up once.
11th and 12th standard, like 6th to 10th, it's left to you. I think we spoke long back in one of the previous session. 6th to 10th, it's always left to you. You want to brush up your basics, you can do. Apart from that, 11 and 12 will more than suffice. Accompanied with Gocheng Leong, it's more than enough.
Okay, sir. Thank you, sir.
Am I audible, sir?
Go ahead.
Am I audible, sir?
Audible. Yeah.
Am I audible?
Yes, you are. Yes, you are. Yes.
Yes, sir. I can't understand how the north and southward mountains are raised. North and southward mountains.
Okay, you
Yes,
got this idea clear? Boat able to move up and down.
yes, sir.
This is fine, isn't it? See, this is
North.
okay. It's fine.
Yes, sir.
The thing
Yes, sir.
is,
But how the mountain ranges are uprised? You
again,
said rocky and up this. This is okay, sir. No problem.
it's more of a fail theory, but still, since you should understand the theory, I'm explaining this. But plate tectonics, we'll get a different explanation. That'll be much easier to decipher. The thing is, let's draw one contour. We'll have a simpler one. So just like a boat which was designed that way, you can move up or down. North America is a continent which is having a similar triangular structure. The boats is much easier to push up and down, very difficult to push it on the side, right? Similar to that, it's
Yes, sir.
difficult to push North America to the western side. Now, that's what I'm attempting to do. You see the podium here. I try to push it. See, if there is no resistance, it will move like this. You get the idea? Like without any resistance, I just pull it. It should be very, very smooth coming to me. The bottom portion is giving more resistance because there will be resistance if you push the boat towards the western side. If resistance is there, bottom portion will catch it. Top portion will fold as mountain. This is mountain. Got it?
Okay, sir. Okay, sir. Thank you, sir.
Ah, sure. Thank you.
Am I audible, sir?
Go ahead. Yes.
Sir, I was not there while you are talking about the first four slides, sir. Can you able to explain that once again, sir?
Slide, ma'am. First 4 slides of what?
First four slides, sir. First four.
Charts.
First four.
Second. We would have had the lesson done for sure.
Second and third. Before.
This is fine. See.
While starting the lessons.
Here you
Yeah,
don't
yeah.
have it. I just written few words. That's all. The thing is,
Area of
I'll
the.
paraphrase it for you. Finding what exactly is going on in the interior is very difficult. The primary reason being it is not physically possible for us to go to one portion of the earth and try to explore. You get the idea? You take
Mm.
your initial study of the earth's interior, it can only be done through indirect sources. I can't do it directly. I can't dig something 2000 kilometers, 2500 kilometers and extract a material. Because of this, the first source which they relied on is if I cannot go in, I will try to rely on materials which come out. So through volcanic eruptions, they collected materials and tried to analyze. That's point one. All right. Number two, second method was regarding materials which were excavated during mining and oil drilling. The point you need to understand is that mining industry and oil drilling industry are becoming more prominent in early 20th century because petrochemicals are understood to be important components. So why oil drilling? Because government is not going to finance money, okay, for research, but same government will finance money for extracting oil. So you associate yourself with oil drilling and mining companies, then naturally you'll be in a position to extract more material. So this works well. Finally, the last one, third material, is your meteorites. Meteorites are any cosmic objects which are able to reach the Earth's surface. Usually this doesn't happen because once you start to re-enter the Earth, you will face enormous amount of friction from the atmosphere. So naturally all these rock materials will burn. If by any chance, like 0.001%, the material is able to reach the Earth's surface, you can take the material and try to study. Now you might be thinking, this external object is completely unrelated to my interior. Now why should I study this? Thing is, if you're having a cosmic object and if it's very close to Earth, if it's falling on the Earth, there are very good chances it is part of the Earth's solar system itself. Is it not? So if it's part of the Earth's solar system, then it's much, much better that this can resemble some interior component of the Earth. So by studying this, maybe you can try to predict what is possible. So this was the initial studies, but these initial studies were ineffective. You can only do guesswork. You cannot do concrete work, and you need concrete experimentation, observation, measurement in science. So that is when they associated themselves with earthquake studies. So this is the field which is called as seismology, and only then we went to primary waves, secondary waves, focus, and epicenter. Is it okay?
Thank you, sir.
Hi, sir. Good evening. Can you explain on the differential gravitational force?
Okay. The differential gravitational force is simple. Like, see, two bodies are there. Two bodies get attracted. That is technically a gravitational force. So if you take DGF in the diagram, hold on a second. Let me go there. DGF is right. See, you're talking about two large continents. Large continents, okay, very, very large. Naturally, they will get attracted towards each other. So due to attraction, they're colliding. That is differential gravitational force, being attracted by the mass of the other continent. Got it?
Okay, sir. And one more thing related to the geomorphology. Which book in the physical geography do we need to study the first few units, or which one we need to refer?
Yes. Fundamentals of physical geography, volume 1, like 11th standard volume 1 NCRT. Like these discussions will be there in chapter number 2, chapter number 3, and chapter number 4 will come. Like that's the next class. Okay.
Okay, sir.
2, 3.
Will we get at least one question related to this series in main? Will we get one question?
At times you may not even get one question. I said maximum one. You may get 0 questions from geomorphology also.
Okay.
See, that is why geomorphology I have only 3 classes. Climate I took 7 or 8, I think. Climate was more extensive, isn't it? See, weightage is given based on proportionality.
Okay, sir. Thanks.
Sir, I think you can hear me, right?
Yeah. Go ahead. Yes.
Yeah, so my doubt is regarding this primary waves and secondary waves in the body waves. You just told that the body waves travel entirely internal, that is interior
Yeah.
to the surface of the. So here in the second observation and third observation, I just have a doubt that you are telling that because of the presence of liquid in between, they were able to travel only till something like 105 degrees, that is from the area of impact. So this one you are speaking entirely internal, not on the surface because of the water in the Pacific or no.
I'm not saying that they're traveling along Atlantic Ocean or Pacific Ocean. I'm saying that they're traveling
Yeah.
beneath like this.
Yeah, so at the first instance, I just got it wrongly because in between the ocean is there and it won't be able to travel because you just
Remove
told it won't be able to travel through the, yeah. So it is internal to Earth, right? So that is the first one.
body
And the
basically.
second doubt is that, yeah, yeah, got it, got it. The second doubt is that how do you distinguish that this is a primary wave and this is a secondary wave? Because based on its impact, do you decide that?
This one, how they vibrate your particles.
Yeah,
See,
exactly. That's what I wanted to know.
one is vibrating longitudinally, one is transverse method of vibration. So you naturally know. And this will reach much faster because it's along the direction. So he's longitudinal, he's much faster. He's slightly late.
Okay, so until unless it is felt, you won't be able to decide whether it is a primary or a secondary, right?
It will be the primary wave who will reach fast because it's a much easier way of transmission, isn't it? When you have particles and you just oscillate them horizontally, it's much easier. This is quite difficult. Like you need to displace the entire thing. So he's faster, he's slower. That is where the time difference also comes. Primary, then secondary. That's why it's called PNS.
Okay. Okay. So in that sense, can we say that the energy or the transmit of energy in terms of distance reached by primary waves would be much higher when compared to the secondary waves?
Yes, accepted. Correct. Accepted. Right.
Fine. Fine. Thanks, sir. Thank you.
Yeah. அவ்வளவுதானுங்களா? Okay. Let me just see whether there is anything else. Oh, yesterday's slide is not received. I will remind them, no worries. Even theories will be asked in exams, even though they are not accepted widely. See, they will ask it like this. Tell me why this theory is not successful or why did the theory fail? Possible means question. See, I sent it to the academic coordinator, the previous session slides. I will tell them, no worries. Okay. Ashwin, you can send it to me after Pongal, man, because the mains work is cramped. So I'm already correcting a lot of papers. After that, whether tectonic plates creates earthquake? Yes, please wait for the next class. Okay, one more question is there. Two more, sorry. Either the sea level should have dropped, rising the land masses visible forming the life, or the sea level should have risen, emerging few of the land mass areas between the continents. Any successful theory regarding formation of the earth? Hold on a second. Either the sea level should have dropped, rising the land masses visible forming the earth. Sea level should have risen. I think Vanati, CIOC 2032-535. I think that the question is done because we are not talking about sea level rise. See, think about the first class. It'll be there in your notes. It'll be there in your notes. Lithosphere formed first. Land was already there. Outer surface cooled. Water came later. Later only water is coming and filling. Okay, whichever area where depressions, there water fills. This is the theory of formation. We saw this, origin of the earth, long back. Igneous rock. We have seen basalt, which is denser than granite, but still found in the earth's crust. Wouldn't the solidification work here? Ma'am, it's this. Okay, let me put it this way. You are forming the rock only on the crust. It's not that the element was already there. It's not that the earth was molten and from the molten surface your solidification. It's coming out and there it's getting solidified. It's directly on the crust. It's not going to sink further. Not possible at all. Second one, does S waves create more damage? Again, remember, compared to P waves and S waves, the largest damage is created by surface waves. Because P waves and S waves, when they travel along the Earth's interior, they will lose most of their energy because they are transmitting. Tertiary waves, on the other hand, tertiary waves or surface waves oscillate the surface itself. This is their mode of transmission. So even if they have less energy compared to P and S waves, their impact will be much, much more because they directly hit you. You are standing here. You will try to dance. Okay. I think the questions are answered. That's the last one. Fine. So shall we close the session? No more hand raises also. One more is there. Okay, yes. Name of Wegener theory. It's called continental drift theory or theory of continental drift. You've had it now, theory of continental drift. Enabled, huh? Oh.
Can you hear me, sir?
Yes. Go ahead.
You have answered my question, but the thing which I want to put a reminder on is with the equatorial climate.
Still not shared. I will tell them. I will.
No,
Okay. I see. I even gave them this particular clip, 43 minutes of this previous session. You take it and share with the students. I'll tell them again. Thank you. Thank you.
thank you, sir.
Ashwin, we won't be dealing with surface waves in detail. Like we will discuss that in earthquakes. We will have to see earthquakes in the next class, but it won't be in detailed description. Not required for exam. That's all. Within surface wave, we have two classifications. We have Rayleigh waves, love waves, but we don't want that level of detail. Maybe more optional kind of style. Not this. Fine. So that's the last one. I'll save the presentation and then I will ask them to share both the previous day's presentation also. I've already sent them. There is some delay. Okay. Stable formula of uranium. It's 238, 92 U238. U238 is more abundant. No, hold on a second. I don't think you can say that. That's not the right way to say it. Sorry. See, anyway, uranium is going to be radioactive. So between 235 and 238 is 235, which is more, what do you call, which is used in nuclear weaponization and nuclear technology. Reasons I'll come back later. I don't recollect immediately, but it would be incorrect to say uranium. You cannot have a stable formula for uranium. Like uranium has to decay to other elements. Only then you can have stability. Uranium itself is unstable, whatever state it is. Okay, be it 238, 235, it is unstable. So thank you. Hopefully see you next weekend. At least I'll finish GM morphology. We'll see to that. Bye.